to understand what this work done really is, and let's begin to ask a couple of more questions. We told you the example of the trolley, right? So in the trolley, what happens is you apply a force in a particular direction like that, and the trolley moves in a direction like this. So how do you find the work done? Now clearly, all this force that you apply in that direction is not working on moving the trolley. Some of it is not being used at all. So in order to understand this, let's take a very simple, nice example. There's a car on the ground. Let's look at it from the top. So if you are looking at the car or whatever the object is, and now I'm going to ask somebody to pull the object that way, and another person to pull the object that way, right, on the ground. Now if two people are trying to pull it in those directions, how do you think this car would move? He wants to push it that way, or pull it that way, he wants to pull it that way, what's going to happen? The car would end up moving in a direction that's somewhere in between both of those depending upon how strongly they do it. In other words, there was once when I was riding the bike and I wanted to go straight, right? And my friend immediately said, hey, you have to take that left. So in somewhere in my mind, there was a confusion. So I wanted to go straight, I wanted to go left. It was a little bit of I did not know what exactly I was doing. I ended up going what they call diagonal. So the resultant of two things, one along this and one along that, ends up being somewhere along the diagonal depending upon who applies a larger force. Now why are we saying this? We're saying this because can't we now replace these two people with just one person pushing it along the diagonal? So if I were to ask you, you look at only the car or the object and I ask you, are there two people pushing like this, therefore the object's going like that, or it's just that one person pushing it that way? Would you be able to answer just by looking at the car? You wouldn't. The effect of both is the same, which means that now I can take our trolley. Imagine a person pulling it that way. The kid who usually is pulling it like that, and the trolley is moving like this on the floor. Now, I can forget the man or the baby who's pulling the trolley and imagine that force that the baby applies as one force applied upwards and one force applied horizontally. Now, what that means is that force that's applied upwards is doing nothing, right? How much of a force is applying, right? As long as the trolley doesn't fly up, a little bit at least, no work is being done as far as that force is concerned. So the only force we care about here is the horizontal force. How exactly we find out from that force how much this force is? If you're curious enough, go and find out about it. It's a very easy thing to do. But as of now, we're going to tell you the only force that matters is the horizontal force. And in most cases that we care about, we're not going to make forces act at these kind of weird angles. We're going to make them act either along the direction of motion or exactly opposite the direction of motion. Anything that happens in between, we forget for a while. Case 1, what have we told you? We've taught you and already told you how to find work done when you know force and displacement, and as long as they're along the same line, either this way or opposite. So we're asking you to wait for all other forces. And second, we've also told you how to find the work done when the force is constant. What if this man is pushing the clock, but he's increasing the amount of force he's applying at every single point of time? Then how do you find the work done? Because 1 second he's applying 10 newtons, next second 20 newtons, so on. That's going to become quite hard. What could you do? Every second or every little minuscule amount of time, find out how much work he does. Next amount of time, how much work he does. Next amount, and you could keep adding them, right? That's pretty hectic. You would later learn that this is called integration. Cutting it into so many small pieces, adding all of them together. We're not going to talk about it. So what are we telling you? Let's find the work done for forces and displacements along the same line and for a constant force. So when these assumptions hold, then the work done is force into displacement. And it's positive if they act along the same direction and negative if the force and displacement are in opposite directions.